Good afternoon, everyone. Give us about one more minute and we will start this webinar. Good afternoon, everyone. Welcome to today's webinar. It's 3 o'clock and we're going to go ahead and get this webinar started. I'm Amy Miller, the National Director of the Asphalt Pavement Alliance, and I'll be the moderator for today's webinar, Asphalt Production and Construction for Civil and Geotechnical Engineers. Before we get started, I'm going to go over a few housekeeping items with you. First, let's talk about the RCEP information. The Asphalt Pavement Alliance has met the standards and the requirements of the Registered Continuing Education Program. Credit earned on completion of this program is going to be reported to RCEP at rcep.net. A certificate of completion issued to each participant registered, so we register each email address. As such, it does not include content that may be deemed or construed to be an approval or an endorsement by RCEP. The learning objectives today, the attendees should expect to learn how asphalt is produced, how asphalt is laid, and ways to improve the end product design consideration. Professional engineers who register and attend the entire webinar as an individual will be rewarded 1.5 professional development hours. APA's webinar program awards PDH credits only to the registered individual, and that's the email address that you use to sign up for this webinar, and not to other members of a group that view the webinar together. To be eligible for the credits, individuals must remain signed in for the entire webinar, waiting for any question and answer following the presentations. All verified online webinar attendees will be to rcep.net. This is a free service that tracks continuing education, again, with the email you use to attend this webinar. You'll be able to download a certificate once you go onto that website and put your email address in. And those will be reported to RCEP within 4 weeks of this webinar. Now I'm going to go over our Zoom controls. The attendee controls appear at the bottom of your screen. You'll see the audio settings in the left corner of the panel. You can click on this to change your speaker settings. We find that using your computer audio really works best. If you have an issue, just exit the webinar and rejoin. Next, you should know the chat function will be disabled during the webinar. Please use the Q&A for any questions. If you need something from the host, I'll be behind the scenes along with Liz Price. We'll be watching that and we'll be glad to help you. For Q&A, open that area and you can type in questions and the host and panelists will receive those. We will be taking questions at the end of the webinar. So during the course of the webinar, if you think of something you want the panelists to ask, just go ahead and type it in. And then at the end, we will go over those. If we run out of time for the questions and answers, we'll make sure we get those in written format to all the attendees after the webinar. At the conclusion of the webinar, you're going to be redirected to a short survey. We would really appreciate it if you take a minute or two and just complete that survey. It's really helpful for us in terms of continuing to offer topics and information that's useful to you and helps us improve as we move forward. So let's take a minute now to get to know our speakers. Our first speaker, TJ Young, has over 35 years experience in the asphalt industry, including 15 years working for front plant manufacturers, 5 years working as a regional manager for material producer and contracting company, and since 2000 has served as a full-time consultant to the industry. Since 2012, he has also served as a production manager for Duval Asphalt in Jacksonville, Florida, in charge of mix production and quality control while maintaining his consulting and training schedule. He's actively involved in developing technical materials in the area of mix production and plant efficiency for the National Asphalt Pavement Association, the National Center of Asphalt Technology, the Asphalt Institute, and has helped develop training and qualification programs in the area of mix production for several state departments of transportation. Considered the asphalt technical expert, Steve McReynolds, our other panelist today, brings over 20 years of industry knowledge as the Director of Operations for Asphalt Tech Solutions and Engineering. As the District 5 Bituminous Coordinator and District 2 Bituminous Manager during his tenure with the Florida DOT, he is known for his consultative and technical advice, which provides strategic problem solving with a variety of solutions. His broad spectrum of construction knowledge, threshold engineering inspection, construction site environmental inspection, and CMEC certified concrete cylinder compression strength, and extensive application of project specification requirements makes them a valuable resource to ensure customers are always compliant with state and local government regulations. And with that, I'll welcome our panelists, and I'm going to turn the program over to TJ.
Good afternoon. Today we're going to take a tour of a modern asphalt plant facility. Modern computerized plant facilities are going to make an asphaltic concrete mixture by mixing rock and sand, which we refer to as the aggregate in our industry, and liquid asphalt cement, which is frequently referred to as a binder, based on the job mix formula established in the mix design process. On the back side of the plant here, you can see multiple stockpiles of material. And asphaltic job mix formulas are established in a wide variety of different designs. As a general rule of thumb, the larger the aggregate, the more load-bearing capability of the mix. So your most extreme example would be interstate highway mixes and, say, tennis court mixes or private parking lots. Larger aggregate in the one, smaller aggregate in the other. Fit and finish is going to look a little different, but this is why you're going to find multiple stockpiles of different materials at a modern plant facility. Come around to the side of the plant here, and we're going to see a video shot of these asphalt tanks that you'll see right here. And it's going to come up on the screen here very shortly. Different types of asphalt cements are stored in these tanks. In most modern facilities, we'll have multiple tanks because we're going to use different types of binder, asphalt cement, for the job mix formula. Some will have performance enhancing additives in them. And so in a modern facility, you're going to see different sizes of material. You're going to see multiple asphalt tanks, and the mix is going to be produced in the process we're going to explain right now. Now, all this is computerized. So most computer plants are highly automated. Here you see the operational main screen when the plant is being run. On the right-hand side of the screen here, if you can see my mouse, will be a data manager where you can pull up a different job mix formula. You set your production rate that you want to run, and then you go ahead and initiate the production process. These modern plants can produce mixes and change them on the fly, so they don't have to stop the process. They can move from one design to the other design. Different aggregates are going to be placed in these hoppers or cold feed bins. And below these particular bins or these hoppers, you're going to see, and in the middle of your screen here, they'll have belt conveyors that are positioned below these feed bins or these hoppers. And these are calibrated for output based on the flow rate of the bin itself. So the material is ratioed out of these bins, and it comes up into the plant process based on the job mix formula. And I'm going to pause the screen here again for a second. And here you can clearly see the sand particles that are sitting on top of the granite particles, which are actually a combination of 1/2-inch rock, 3/8 rock, stone screenings, and natural sand going into the process. Now, positioned between the collecting conveyor, the feed bins, and the plant is typically a screen. This screen is not used for sizing. This screen is used to keep oversized or tramp materials from the mix. And if you look carefully here in the middle of the screen, you'll see a plastic bag that's been caught on the screen. And that's essentially exactly why the scalping screen is positioned in the process. This is to keep a deleterious material, tramp material, accidentally getting into the mix. This is a continuous operation, so we want to scalp out and keep these products from getting into the mix prior to making into the drying and mixing drum. Now, downstream of this particular scalping screen, there's going to be a conveyor going up into the plant. Positioned in this conveyor that is right before the drum that we see up here is going to be a belt scale. This is going to measure the flow rate of the material that's going into the process while it's happening. So some states refer to this as a weigh-in motion scale. So this is a continuous weighing operation. It's very important because from this, we're going to measure the actual flow of the material going into the plant process, which is then going to be tied to the asphalt metering and pumping system later in the process so that the proper amount of binder is always maintained with the proper flow of the aggregate material. Now, petroleum products are used to produce asphalt cement. It's the bottom of the barrel of the crude oil. And we all know that oil and water don't mix. And so what's unique about an asphalt plant is that we have to dry and heat and remove all the moisture from our aggregates so the asphalt cement will stick to that particular product and make the binder that holds the entire mix together. This is most cost effectively done with a rotary type rock dryer. Other types of heat transfer processes have been tried over the last century, but the most cost effective and highest production rate way of producing mixes is with a rotary rock dryer. Embedded into this rock dryer is a burner. So the material is actually going to enter this rock dryer, and it's going to work its way toward the flame, and it's going to be drying and heating in a hot gas stream. And here's a video clip that shows the material actually tumbling inside the dryer and working its way toward the flame that's embedded inside this rotary dryer. So this is what a dryer looks like on the inside when it's actually functioning. Now, if you've ever stood on a beach and the wind is blowing 40 or 50 miles an hour, you'll know how the wind can pick up sand right off a beach and deposit it right in your face, your eyes, ruin your $150 sunglasses. What's happening inside this rotary dryer, because when moisture turns to steam, it expands thousands of times, is that we have actually created a hot gas and steam environment here that has an airspeed of 50 to 60 miles an hour. And so the fine sand particles and the dust particles get evacuated with the exhaust system that is pulling the steam out of the process. This is like not exactly intuitive. It's a little counterintuitive, but it's critical in an asphalt plant that we actually collect these fine sand particles and these dust particles and return them to the mix, because our job mix formula has been established with these small sand particles and these dust particles to be an integral and critical part of the design process. So here you can see the ductwork that's leaving the dryer. In this ductwork, steam is being evacuated, and with it, small sand particles and dust particles are being drawn out of the system. Again, I can't stress enough how important it is to collect these fine particles and then return them back to the process. And this is what really complicates the whole process of an asphalt plant. So on this box on the left, this square device, this is what we call the primary collector. The small sand particles are going to fall out of this device. And if you can see my mouse adequately, you'll see there's a chute and a little square box that's a tip valve on this particular plant that allows these sand particles to come in this duct, slow down. If you look at the cross-sectional area of the duct and you look at the cross-sectional area of this square box, significantly different. So the particles come in and they slow down. There's a plate actually that's designed into this wall, strikes this plate, hence the term on the street knockout box. Sand particles fall out and return right back into the drying drum. The fine dust particles are going to carry on, and they're going to carry on into the other larger device, which is called a secondary collector. And again, I'm going to pause the screen and you'll forgive me, but on the back side of this secondary collector is an exhaust fan. So it's drawing that steam through. Now inside, there is hundreds and hundreds of filter bags that are suspended on cages. And the flow of the air is reversed back through these bags while the plant is operating. The dust falls into the hopper of the secondary collector or bag house, and it's collected in a screw conveyor in the bottom, and that screw conveyor feeds another screw conveyor that returns the fines back up into the process. So now all the fine particles and the sand particles are captured. Learning how to run this process, learning how to control the heat in the plant, learning how to run the burner, and learning how to return the fines back into the process is a very important skill set for an operator. A good analogy is think about flying an airplane. All planes function the same, but each brand of plane is going to fly slightly different, or sailing a boat. And it's not a simple matter of running these plants of just pulling up a mix recipe or a job mix formula, setting the production rate and hitting the go button. You've got to control not only the recipe that you're selecting, the job mix formula that you're running, you're going to have to control the heat, control the temperature, control your draft, which also affects your dust collection and dust return. This is done very effectively, but it's a very important skill set for an operator. Now, asphaltic cement can be produced with a large percentage of reclaimed asphalt pavements, previously used pavements. We call this RAP in our industry, reclaimed asphalt pavements. And so the plant will have RAP bins, and we'll have another collecting conveyor, another scalping screen, another belt scale, and another conveyor that with a scale in it that returns the reclaimed asphalt pavement back into the plant process. So here you can see the belt scale, you can see the RAP going up into the plant. What's actually happening inside is the aggregates being superheated convectively in that rock dryer, which is then conductively heating up the RAP so that the temperatures are stabilized. Both the virgin aggregate and the RAP aggregate are both dried. And now we're gonna meter the asphalt cement. You'll forgive me, I hope. Good filter water. And we're gonna, excuse me. This rarely happens, but occasionally it does. So now we're going to ratio the asphalt cement back into the process. The asphalt cement's going to pump and meter and be measured and go down this line. And it's going to be introduced on this plan into the mixing room. So the asphalt cement is introduced as the last step of the process. Not all plants have external mixing drums like this plant does. This plant has both a drying drum and a mixing drum for the liquid asphalt cement. This plant is one of the designs of a higher RAP percentage plants that are frequently being built in the United States. This plant has actually done some research projects on up to 60% RAP mixes on an R&D basis. So Florida, where this plant is positioned and placed, produces mixes up to 40% RAP regularly. Other plants that you'll see will be doing everything in just one drying and mixing drum. Sorry about my voice here. Amy and Liz, I'm really sorry about that. Now the final mix is now going to be transferred into storage silos. Modern plants will have multiple silos, and that allows you to run different types of mixes, feed different types of jobs, and have different types of mixes for the plant facility. Let's just pause here for a second. Not only do I need some more water, but this allows us to look at the whole process now. You can see multiple types of stock of aggregates in the back of the yard. On the left of the screen, you can see multiple asphalt tanks, and you can see the drying and mixing drum and the silos, the coal feed bins. So this is how the process actually works. Now, mix will be dispensed from these silos, and it'll be computer controlled weighing and loading trucks out of the silos out and send it out to the job mix formula. Most of these silos are heated and insulated, and so you can store mix for a long period of time, even multiple days, if you're in a jurisdiction that allows that. The mix is tarped in the truck, temperature's taken, and we send the mix out to the job site. Steve McReynolds is now going to explain how this mix is actually placed in the field and we actually pave out on the job site.
Thanks, TJ. So prior to the paving operation, key considerations must be addressed. We usually do this with a tailgate meeting, which consists of the paving crew, the paving foreman, and the quality control technician. Topics that can be discussed is the type of mix that we're going to place, the thickness, or any issues that someone may point out that could come up during the paving operation. So following this tailgate meeting, we're going to run through a paving checklist with the paver. First, we're going to heat the screed. It's important that we heat the screed so that this metal screed doesn't tear the mix or tear the mat as it's being placed. From there, we're going to center our toe points. This will later be used to adjust for the height of the paving mat that we're placing or the thickness of the paving mat. We're going to set our paving width. This should have been done during layout with the paving crew, and we need to set that width so we can maintain these mats throughout the paving operation. we're going to set the crown of the main screed. So the street can be paved, or the mat can be paved with a crown in the mat, or flat, or actually can be an invert in the paving mat. We're going to set the slope extensions. So these can be set at the same slope as the paving screed, or they can be at a different slope, such as if you're paving a shoulder outside of a mainline paving. Next, we're going to lower the screed into starting position right down on the surface to be paved. And then we're going to null that screed. That's done by turning the height adjustment, the manual height adjustment, clockwise until it's free, flows freely. We're going to set our end gates down on the surface being paved. This is going to assure that no mix comes out past our paving width that we're wanting, and also makes a nice vertical longitudinal joint. We want to set our auger 2 inches above the height of the mat that you're placing, or the thickness of the mat that you're placing. We also want to set the feed sensors. This will assure that hot mix will be kicked out by the auger out to the edge of the wings here during the paving operation, so we don't starve the outside of the mat. Next, we can fill the auger chamber with hot mix. And pull off from a starting point. Now, prior to placing hot mix, tack, which bonds layers of asphalt together, must be applied. A clean surface is imperative and should be swept or blown before this application. Tack is typically an emulsion and must break before laying the asphalt. As the emulsion breaks, water evaporates and asphalt is left on the roadway or the surface to be paved. You'll notice a change in color from brown to black as the emulsion breaks. You want to make sure that every area to be paved is coated with tack. So once the tack breaks and you've completed your pre-paving checklist, you're ready to pave. As the truck arrives, the dump man will safely direct trucks into position. He will make sure that the paving hopper is 1/3 to 2/3 full at all times. As the mix enters the hopper, it's carried by the conveyors to the augers. The amount of mix carried to the auger chamber is regulated by variable speed or by flow gates, which will strike off the mix. So here we go. Going down the conveyor, here's your strike off gates, which can be adjusted vertically. We're headed back to the auger. And then right down to in front of the screed. So then the screed's going to take the head of material and it maintains the correct thickness as the material creates a mat. The screed also maintains the angle of attack. So this correct thickness is also achieved. So they can also help with achieving the correct thickness. It's important to keep that head of material in front of that street at all times, a proper head of material. Behind the paver, a rolling pattern is established in order to compact the mix to the appropriate density. The established rolling pattern determines the number of passes the roller will make behind the paver. This is a large steel wheel roller getting initial compaction of the mat. Following the steel wheel roller is normally a pneumatic or traffic roller. This is the finishing roller and adds the last little bit of compaction to achieve density. Prior to paving commercial jobs, there are numerous considerations that must take place. The design of a parking lot is vital to the success of the paving operation. When not designed properly, parking lots can experience maintenance issues and also a shorter lifespan. The paving equipment is set to a certain size. It's physically impossible for the equipment to reach every nook and cranny in the lot. Think about a bullnose over here on your landscape maintenance areas. The paver paves in straight lines. It cannot move around the arc. So handwork must be employed in these areas. Now keep in mind these areas with the handwork, it's going to look different than the mat that came from behind the paver. It's not going to look as smooth. It's going to have a little rocky appearance. But rest assured that if it's properly compacted, it's going to last just as long as the mat that comes from underneath the street. However, aesthetically, it will look different. Base installation is extremely important. Imagine the parking lot as a cake. The top asphalt layer is like the frosting, and the base layer is like the cake. The frosting is only as good as the cake beneath it. The cake is not a good foundation if it's weak and full of cracks. Compaction of the base is extremely important to the proper performance of the asphalt. Be sure the subgrade is properly prepared and compacted prior to laying this aggregate base. Also keep in mind the slope of the base will determine the slope of the asphalt. To ensure proper drainage, the base must be installed at the proper slope. The asphalt will follow the same slope when it's placed. This is pretty important. We can pave slope with asphalt, but you won't get a consistent thickness. It'll go in as a wedge if you're trying to create slope with asphalt. Normally in a parking lot situation, the designer has specified uniform thickness. So the asphalt subcontractor really needs the base to have the slope there in order to achieve the proper thickness in the parking lot. While the aesthetics of a parking lot are important, other variables should be considered. What does your traffic load look like? Is your area prone to a great deal of rain? Be sure to select the proper mix and determine the appropriate thickness for each lift. We mentioned how important the slope is when constructing the asphalt base to ensure proper drainage. Another consideration when thinking about drainage is to make sure there are enough drainage structures in the design to quickly and completely remove the water from the surface. At the completion of paving, this is the last thing you want to see is a parking lot with heavy ponding across it. This will cause long-term issues with the asphalt. It could cause stripping, which will debond the asphalt from the aggregate. It will ravel out and create potholes. It's not a good scenario. We really need to get that water off of these parking lots. Taking these considerations into account prior to the paving operation will help the overall job run efficiently and be a success.
Amy, you're muted. You there? Thanks,
Yes,
TJ.
I am. I'm sorry. It took me
No
a second
problem.
to get to the controller. Mhm. All right, very good. Well, we have some questions for you all, and we'll start right off with the very first one. Can the dust and sand particles that are removed from the drying phase be accidentally returned to the dried aggregate mix as clumps of dense sand fines get coated with asphalt oil and show up in the mix as a coated lump that is a negative component of the mat? We've had this happen, and the response was that the clumps dropped down from the collection system. You want to take that, TJ? I think that was during your time.
Sure, yes. This can happen if the dust collection system is malfunctioning. What was described here is probably tramp air being brought into the baghouse, which is causing it to fall below dew point, and that'll cause the moisture that's inside the dust collector itself to go back below dew point, and then it makes the dust particles clumpy and wet. And when they're returned back to the process, then you can have that condition show up in the mat. That's a baghouse malfunctioning problem in all likelihood.
All right, the next question is there a general rule of thumb on how thick the mat needs to be paved compared to the thickness it will be after compaction?
I'll take that one. So it depends on the type of mix you're laying and your ingredients or your part of the hot mix. Usually, if you're laying like an inch, you might be putting down an inch and a quarter. So your compacted finish will be 1 inch, which is what the design's looking for. So I think that answers it.
The next question is for you, Steve. It was a question pertaining to the video. This person wants to know, what is the guy who is standing on the back of the paver and poking the mat doing?
Okay, that's a good question. So he's checking the depth of the mat. So he's got a metal rod there with a big flat washer on it, and it's set to the depth of what he's placing. So, like I said, our finished mat might be an inch, and he's placing an inch and a quarter so he can get that compaction roll down. So he's got that set at an inch and a quarter, and he's just touching the mat and checking the thickness.
All right, what are your thoughts on paving ADA parking spaces with asphalt? Can the 2% maximum requirement be achieved?
Yes, it can. It's not the easiest thing to do, but I see it every day with Duval Asphalt. They pave these parking lots, and that's the main concern, and that's something that should be discussed up front in that tailgate meeting. You know, how we're going to accomplish these ADAs, because in the inspection process, that's the main thing that people are looking for at the end of the paving process. But yes, it can be done.
Some drum plants can handle more percent wrap than others. What's the reason for this?
Generally, it's a length of time in the process. So the longer the drum, the more you can get the material can be heated and dried. It's more effective. So drum length becomes an issue. It's also the positioning of the recycle collar relative to the burner. And so they're what we call early wrap entry plants, and then there's standard wrap plants. So the shorter drums that have a wrap collar positioned further in the process, closer to the mixing area will not be able to effectively dry and heat wrap as well as ones that are longer and it's more separated. You know, the the high wrap plants that are being produced the last 5, 6, 7 years, 10 years have a very long drying drum, a very long heat stabilization chamber where the wrap and the virgin wrap material are able to be heated together, and then a long, you know, mixing area. So they're not all created equal, and it also varies, you know, like on wet days. So if you have a very wet day, you may find your plant does not work as well at a higher percentage of recycle if you've really gone through a large rainstorm. So these are practical physical aspect considerations on the plant design.
Here's an interesting question. How do you reduce oxidation during laying of asphalt in hot
Amy, could you repeat that? Because
Kind of cut out at the end.
you know, we
areas?
didn't
Okay,
hear it.
how do you reduce oxidation during laying of asphalt in hot areas?
Proper mix temperature. We make sure we don't get it out there too hot. That really helps with reducing the oxidation.
Enough. What temperature, speaking of which, should be achieved in the dryer when using wrap?
Wow, that's like a $60,000 question. The temperature that's going to be inside the dryer is a direct function of the percentage of wrap that you're running and the moisture that's in the wrap. So the higher the wrap percentage and the higher the moisture that needs to be dried from the wrap, because you're heating up wrap conductively, that's touching heat, as opposed to the hot gas stream, which is convective heat, you may be pushing your aggregate temperatures to 800 or 900 degrees or more. When the wrap is introduced, then it'll rapidly come down. And this is why it's important to get the wrap mixed with the virgin aggregate and let the temperature stabilize before the liquid asphalt cement's added to it, because that'll affect some properties of the binder. So that's a great question, and there's a lot of physics going on there.
All right. What company builds the plant with separate heating drums for aggregate before the aggregate goes to the mixing drum?
All of the manufacturers can build a two-piece plant. So you can have a drying drum and an outside mixer. Now, these outside mixers do not always have to be mixing drums. So you can use a continuous pug mill type mixer. And these are being built. So any manufacturer can build you a two-piece plant if you desire to do that. In fact, that's a popular way of converting a batch plant, which is an older style plant that we typically don't produce too much of anymore, into a continuous plant by just eliminating batch tower and putting a mixing device there. So you have a drying drum and a mixing device. Hope that answers the question.
All right, so the next person is asking about a certificate for participation. So again, within 4 weeks, you'll be able to go to rcep.net and download your PDH with the email you used to sign up for this webinar. We will be sending all registrants information about this. We'll send you information that gives you, again, the same instructions we're telling you, so that you know exactly where to go to download your PDH. All right, moving on to the next question. If the driving time from the plant to the site is 10 minutes, how fast will you instruct the paver to move? I think it said in meters per minute, perhaps. Explain how you arrived at this speed of movement.
Sounds like a Steve question to me.
Well, I guess it's what you're paving is going to predict your movement too. So if you're paving a parking lot and you got to do a lot of parking bays as well as mainline paving, it's, you know, the pace is just going to be set by what you're paving. The distance from the plant to the paving site is really only matters for the number of trucks you're going to use. So if I'm a long way from the plant, I'll need more trucks so I can keep that paver moving throughout the whole day or throughout the paving shift. If it's real close, I use less trucks. But the pretty much the feet per minute or meters per minute of the paver moving is dictated by what you're paving.
Right. How do you deal with asphalt joints to get the proper compaction?
Well, it's best that you tack those joints really well and that you use a good compactive effort on the joints. If you're paving up against a real cold joint, you might want to actually cut that cold joint back before and tack before you pave up against it. That can help with density. It's a real art. There's a lot of quality control people out there and paving foremans that work really hard at getting compaction on those joints, especially in airport situations or FAA type projects. And it's an art, and it's just a lot of practice and a little bit of luck.
All right. Do we need to do curing for asphalt similar to concrete?
Um, in a parking lot situation, sure it is, because you'll get what we call power steering marks on top of the asphalt. It's where people park and they turn the wheel back and forth, and it kind of leaves a mark on the top of that. Um, but as far as asphalt, as soon as it gets below 160 degrees, you can drive on it. All the compaction is there. You've achieved all you're going to get. It's not going to compact anymore, and you can actually drive on it. But cure time, yes. If you want it to stay mark free, and if you can keep cars off of it for a few days or a few weeks, that's even better. But we know in the real world that doesn't happen often. So just good compaction, and that's all the curing you need. Good compaction, and make sure it's not too hot before you do release it to traffic.
If the asphalt concrete fails after testing the core, parentheses, core analysis, what are the remedies?
Can you repeat that last part, Lori or Amy?
Sure. If the asphalt concrete fails after testing the core, and they have in parentheses core analysis, what are remedies?
I guess it depends on what fails. So let's say we analyzed the core for density and we didn't achieve density. Um, like I said, once that asphalt gets below 160 degrees, you're not going to achieve any more density. So it's not like you can go back out there and roll it. It's best to have an engineer analyze what problems that may cause. If it's in a traffic situation and you're not getting good density, it could be a rut. So it would need to be removed and replaced. Um, it just depends on the failure, what it is and where it is, and then what an engineering analysis would determine what could be done. But
All right, the next question, is it true that the asphalt shouldn't be raked along the longitudinal joints?
um, yeah, it shouldn't be. We should be able to lay that joint and at our right amount and roll it right in. It's not going to hurt the asphalt. Aesthetically, it might look not real good, but as long as we get it compacted, proper density, it's going to perform. It just might not look good. And that's probably where that question's going, or where it came from is, some people just like to rake these joints and it just doesn't look good, or backscatter material, and just doesn't look good. We like a nice smooth mat, nice smooth joint. So if you get it properly compacted, probably won't affect it much, but it just don't look good.
Okay, the next question is, what is an acceptable tolerance for asphalt pavement thickness?
That's all depends on your traffic load. If you got a loading dock with a lot of tractor trailers coming in, you're going to need thicker asphalt. If you just have an apartment complex with nothing but passenger cars, you might not need as thick an asphalt. That's in the design phase, and that's your civil engineer will design that out for you.
How can we maintain the proper asphalt temperature through the traveling distance and weather conditions until it's laid?
Placed in a proper haul truck that's clean and tight bed, and with a proper tarp over the top, the asphalt will stay hot. It's incredible that you can take 20 tons of asphalt in the back of a truck and it maintains that temperature, compaction temperature, for an awful long time. I guess it's just in that mass, it just maintains that heat. Um, of course, you might not want to haul it 150 miles; it might cool off, but um, around the plant, anywhere 50 to 60 miles, it's no problem.
During the laying of the asphalt concrete, some people use water to prevent the steel roller from sticking to the asphalt. Is that okay? Others apply oil on the roller.
Water is fine, and down here in the state of Florida, it's a specification that on the steel wheel rollers, you need to have a water system that keeps the asphalt from sticking to that steel wheel roller. Yeah, water's fine. It's you're just going right over top. You're breaking down that asphalt. It's not going into the asphalt. It's just right on top. And the asphalt's so hot when you're compacting that water, it's just evaporating right off anyway, just preventing from sticking to the drum.
Good. TJ, you have a friend from Hawaii that said, thank you for the percent wrap usage question. They've been looking for a good technical answer, and you just gave them one. So,
Well, it's nice to hear from Hawaii. Hawaii aggregate's a little tough to work with. It's very porous, it's hard rock, very hard to get it dry. And so, yeah, I can kind of understand his question.
all right. Was it a counterflow dryer in the video shown? And where was the wrap material introduced? Center of the drum or at the end of the drum?
It was a counterflow dryer. The wrap is introduced after the burner. That particular dryer is about 55 feet long. And so the wrap comes in about 40 feet down, 42 feet down. So you've got the drying zone, the heating zone, the combustion zone, the burner, the flame is in the combustion zone. The wrap comes in behind that. And then there's about 14 feet of discharge down to the mixing device.
Can U.S. plants heat the wrap before introducing into the drum like done in Japan?
Yes, that can be done. It's not very popular in the United States. Typically in wrap in Japan, what they do is they heat. Typically, what I've seen is they're heating it convectively with hot gases. They do the same in Europe. I've been around maybe 20 plants in the United States that have done that, used a wrap dryer. The idea being that you can dry the wrap and possibly get it most of the temperature to the target temperature prior to mixing it with the virgin material. Here in the States, what we've done is we've tried to really work and sort of perfect this idea that we're going to heat the wrap conductively. That's kind of where we're at in the business right now in the industry here, but it has been done in the States and it can be done.
Next question, have you tried or know of anyone that has tried introducing higher moisture, higher calcium carbonate aggregate pond fines into SMA mixes as a mineral filler?
Steve, you want to take this one or you want me to?
You go ahead with that one, TJ.
I've only had one or two phone calls on this over the last few years. Generally what I do is direct them to the moisture and the sizing of that material. So I'm not real familiar with that particular product as a filler additive, but I have fielded that question before. The question that I've received previously was those materials were pretty wet, so they needed to be dried. But it's not common in the United States here in our markets at this point in time.
When using high wrap content, say greater than 50%, do you recommend performing an extraction first before mixing wrap with virgin aggregate?
Steve, that's a design question.
So this is after the process or during the design phase? I mean, yeah, we want to do an extraction of the asphalt on the wrap. We have to know what that percentage of the asphalt is on the wrap. And then of course, the gradation coming in from the virgin aggregate, and how it's all going to mix together in the design. But yes, we want to do an extraction of the wrap. Extraction.
Amy, would you read the question again? Because I think the key word's 50%. Could you read that
Yeah,
question?
so if the wrap content is greater than 50%, do you recommend performing an extraction first before mixing wrap with the virgin aggregate?
I think we'd be looking at not only the extraction, the content, but also the characteristics of the binder. So we want to see, what the recovered PG grade was. If we're going to use a performance graded system, we want to look at certain characteristics of the binder itself when they design the mixes, because that's going to affect the new type of liquid asphalt that you're going to add. So to match with the wrap to get it to the target performance grade in the final end. So that's a design consideration.
Okay. Steve, here's a question for you. What is your opinion on the use of a joint adhesive for longitudinal joints?
I have no experience with it. I've heard a little bit about it. I've heard that it works. I don't know the cost or, the time factor to it. We use tack. It seems to work for us. But if there's something better out there that, doesn't add a lot of time or a lot of cost to the project and you get a little better results, then sure, I'd be willing to use it.
All right. How do you not cross-contaminate different mixes when switching to different job mix formulas on the fly while producing hot mix asphalt?
Wow, it's the $1 million question, right? So what are we going to tell them, Steve? One
Trial and error.
crossover load, 20 tons crossover. So there's the way the material flows through the drum, there is going to be a little bit of a crossover from when you switch mixes. When we're producing multiple mixes for DOT projects and we're using multiple silos and I'm real concerned about it, I'll have them drop some of that mix into the pit. So there's always a reject conveyor on a plant that allows you to drop some of the mix out of the system and not go to the silo with it. As a general rule of thumb, people are kind of worried about, 20 tons of mix, like one load across over a mix. And people use a lot of different techniques, but you can drop that out of the system and just to be completely comfortable. What other producers will do on the street. Now, this is what really happens on the street is that they'll take, when they switch from a finer mix to a coarser mix to a finer mix, they might allow a little bit of that finer mix maybe in that silo. The test results will prove that the likelihood of that cross-contamination is very, very minimal. But if you're really concerned about it, you just drop out, say, 10, 15 tons of mix on the fly. Now, it also depends on how well you've set your timers up in your plant computer. So that's a function of going into your plant computer and you have control of the sequencing of the timing of the material, the wrap, the asphalt cement, and you time it against the length of time it takes as it goes through the plant. And these are the things that you do to really try to get your timer values really tightened up nicely. And that's usually what the factory technicians are very, very good at this when they're setting up a new plant. You have to go through that whole process. But if you're really concerned about mix, I have them drop a load in the pit. And I'm just like, protect the pay, make sure the mix is 100% good, and just, we can always recycle it. That's what's great about wrap. I mean, we can recycle that in the plant process.
If the mixing temperature for a mix is, say, 300 degrees Fahrenheit, at what temperature would you produce the mix if one project is 10 minutes away from the plant versus a second project, which may be an hour from the plant?
Steve, go for this.
I guess it depends on your ambient temperature too. If it's a little bit colder and your specifications allow you to go a little bit over that 300 degrees, they give you another 15 degrees and it's cold out, you got a longer haul, then yeah, you might want to make it towards the hot side. No, here in Florida we have a 30-degree maximum range where we have to reject material, but we also have a spec where we need to be consistent and an average of 5 loads within 15 degrees. So it can be tricky. On a real hot day, the closer project, I might make it a little bit under. I might use that 10 or 15 degrees under just because it's hot, and you don't want any problems, tender mix or anything like that because of the ambient hot temperatures.
Very good. Any thoughts about re-rolling asphalt days after it's been placed to increase or improve density?
Can't do it. Once that hot mix is in place and it's below 160 degrees, it's you're done. You're not gonna achieve a higher density value.
What temperature should the initial rolling begin?
Um, Depends on your mix. Some mixes are tender, but we start breakdown rolling as soon as it comes out of the back of the street. A lot of times.
All
Sometimes
right.
you back off if you have a more tender mix.
And some of the additives that are on the market will affect the mixing temperature and the paving temperature. So you're really getting into some chemistry questions also.
Yeah.
There with that.
But generally, if your mix arrives on the project at 300, by the time it comes out of the back of the screed, you're probably looking at about 280 degrees, and it's fine right there to start breaking it down.
All right. This question is aimed for you, Steve. They're asking, would you recommend RAP for a new highway?
Absolutely. Yep, I'm a true believer in RAP. My whole entire career with the Florida Department of Transportation before I came over to ATS, we used a lot of RAP, and the come to Florida, we got great roads down here, and all the state roads they've got RAP in them. Even our friction, our dense graded friction course, we have 20% RAP in them, and not a problem with it.
Okay. Let's see if I can get this straight. When producing RAP, the aggregate that goes into the dryer, is it coated with binder? If yes, is that one of the reasons the temperature reduces in the drum dryer?
I'll repeat that question again. I want to make sure I got it right.
Okay, it's a two-parter. So the first one is, when you're in RAP, the aggregate that goes in the dryer, is it coated with binder?
Yes, the wrap has binder on it. Right.
Okay, so is that then their second question is that one of the reasons that the temperature reduces in the drum dryer?
No, the reason it reduces is because your wrap is ambient. So if say it's 70 degrees outside, you're feeding 70-degree wrap that might have anywhere from 1% to 5% moisture in it. Okay. And you want your final mix temperature, let's say, be 300 degrees. So you've got to raise it from 70 degrees to 300 degrees. The binder doesn't have anything to do with that heat transfer. The binder is part of that process, the binder in the wrap. So you're just drying the wrap and you're bringing it up to that elevated temperature.
All right, we've got time for just a couple more questions. Right, is there a quick test prior to coring that can alert you of the density before the temperature goes down?
Sure. Yeah, we use pavement quality indicators, nuke gauges, all kinds of quality control tools. But yeah, there's a quick test that you can get a good idea of what your density is going to be if you're in that ballpark of where you need to be before the core is extracted.
What is the temperature behind the burner usually?
It varies based on the moisture, the wrap that you're running, the moisture in the wrap. You want your virgin aggregate to be dried and heated to the requirement by the time it gets past the burner. So it's going to vary based on the field conditions that you're operating under.
All right, so this is going to be our last question, and it's multi-questions here. They're asking, have you ever come across tender mixes? Is the cause in the mix design or the paving operation, and how do you fix them?
Yes, I've come across tender mixes, and it's usually in the design of the mix, and it just kind of depends. It could be your local sand causing it. It could be the amount of asphalt in it or your overall gradation. So there's a number of things that you can change to correct that tender mix. In the field, if you experience a tender mix, you just got to back off with your rollers, get out of that tender zone, wait till it gets to where it's stable and you can break it down and compact it. It's a tough situation when you're out there.
All right, very good. Well, just want to thank everyone for attending today. Thank you to our panelists. They did a great job pulling together this video for this webinar today. We got some great comments already about the video and the presentation. So excellent job to our panelists. Again, you're going to be getting a survey, a quick survey. If you can fill that out, we greatly appreciate it. And we'll also be following up with you. You'll get an email and it'll have a document in it. It'll have all the questions listed and the answers. It'll have a link to this video today where you can go back and rewatch it. And we'll also have a link to future webinars. And we hope you can be with us as we put on more educational sessions in the future. And with that, we'll close out today. Hope everyone has a great rest of the day. Thank you.
Thank you.
Thank you.